Sigma notation is a shorthand for writing out sums. Suppose I tell you I want a sum of n terms, a sub 1, a sub 2, a 3, on down to an. And if I just want to add them up, then I use this summation sign, where this is my index, this is my summation sign, and it just means add all your terms. And I is the index of summation. A lot of times we use i's, sometimes we use n, we can use k. 1 is where you start, and n, this is your nth term. So you have your lower bound and your upper bound. No, you don't always have to start at 1. As you'll see here, suppose I want to sum. I goes from 1 to 6 of I. So every time I change I, I'm going to replace it with the next value. So this becomes I is 1, and then I'm going to click it up 1, plus 2, click it up plus 1, all the way up to 6. And when it hits 6, I stop. What do I do if I have something like this? Well, first of all, I want you to notice that I'm starting at 0. So this is going to be 0 plus 1. I'm going to click this up 1, 1 plus 1, click it up another 1, 2 plus 1, click it up another 1, 3 plus 1, and so forth. I'm going to run out of room, so this is 5 plus 1. Suppose I want to start at, oh, I don't know, 3. I can do that. For this one, this is 3 squared. Raise it up 1 from 3 to 4. 4 squared, 5 squared, 6 squared, 7 squared. Now, sometimes you have things in here that aren't changing. So you see how I have this 1 over n here? How would I write this? Well, this is going to be 1 over n times 1 squared plus 1. Now I'm going to change k to 2. So this is still 1 over n, 2 squared plus 1. 1 over n times 3 squared plus 1, and so forth, until I get to the final term, which is 1 over n times n squared plus 1. Suppose I want something like this. The sum as I goes from 1 to n of x by times delta x. Same thing. This is going to be f x evaluated at the first point times delta x plus f evaluated at the second point delta x plus f evaluated at the third point delta x plus until we get to the nth term. There are some properties of summations that make your life easy. If I multiply every term by a constant, I can factor that constant out. And if I'm adding two sums, if I'm summing two different functions here, then I can break those apart. Now, here are some summation formulas you just need to memorize. The sum as I goes from 1 to n of c is c times n. Think of factoring it out. Now, suppose I'm summing from I goes from 1 to n of I, that is n times n plus 1 divided by 2. What if I want to do I cubed? So I'm going from I to I cubed. That's n squared, n plus 1 squared divided by 4. And it's kind of interesting that this is the square of the I terms. Now what if I'm trying to sum I squared? That's n times n plus 1 times 2n plus 1 divided by 6. Let's do an example. Suppose I want to sum from I equals 1 to n of I plus 1 divided by n squared. Well, the n squared is not part of this, so I can factor it out. All right. Now I know this is 1 over n squared times, I can break these apart. The sum I goes from 1 to n of I plus the sum as I goes from 1 to n of just 1. Now you remember the sum as I goes from 1 to n of I is n times n plus 1 divided by 2. And the sum of a constant is just the constant times n, so this is just n. So let me rewrite this. If I simplify this, it becomes n plus 3 divided by 2n. So for n equals 10, the sum as I goes from 1 to 10 of I plus 1 divided by 10 squared is 10 plus 3 divided by 2 times 10, or 13 divided by 20. For n equal 100, the sum as I goes from 1 to 10 of I plus 1 divided by 10 squared, 100 squared, is equal to 100 plus 3 divided by 2 times 100, or I get 103 divided by 200, and so on.